Welcome back to our channel study guide. So in this section we are very interested to bring out the solution of PSC JEE Electrical 2018. Okay, the exam was conducted on 18/02/2018, that means 18th of February. On the month of February it was conducted, but right now we are releasing its answer key. We have already released its answer key in our website previously, but right now we are releasing it into our YouTube channel. Okay, and we are very much interested about the SSC JEE previous year solution. Okay, SSC JEE will probably bring the notification on the September. If they release their notification on the September, then we would suggest you some preparation strategy and preparation guide for SSC JEE, and then we will start solving the SSC JEE papers, the 12 papers conducted on 2018 February. Okay, so those who are very interested about the SSC JEE, okay, so you can subscribe to our channel. Okay, and you can share our videos of our channel too. Okay, now let us start this exam question paper. Okay, we are very interested in the solution of the previous year exam paper. Why? Because if you solve a lot of questions from the exam paper, that will bring you the idea about the question setter. Okay, and if you solve a lot of questions from book, okay, there is a lot of varieties in the book. Okay, it is a fact that all of the questions are not very important for our examination purpose, right? Okay, if you solve some question paper, that will ultimately bring you a very brief idea about your upcoming exams. Okay, actually this is our thinking, and now let us solve this question paper of PSC JEE Electrical. It is a diploma basis examination. You know very good about that. Now right now we are starting. So what is the first question? Our first question is, where the voltages are high and current to be interrupted is low, the breakout preferred is. Okay, you can find this question in the book JB Gupta. Okay, you can find the JB Gupta 5th edition and page number 406 and question number 138. Okay, you can simply find this question paper on JB Gupta 5th edition, page number 406 and question number 138. Okay, so what are the options given? Air blast circuit breaker, oil circuit breaker, vacuum circuit breaker, and none of the above. The correct answer of this question will be vacuum circuit breaker. And now come to the point why. Okay, the arc extinction phenomenon in the vacuum circuit breaker is related to a great extent up to the material of the contact, the shape of the contact, and the contact geometry too. If we use more than the higher rating, then what will happen? The vapor does not condensed, okay, at the proper geometry, okay, and it will not bring back to the original position. Now that means it should be used up to 33 kV circuit breaker. In India, for rural electrification, 33 kV circuit breaker are preferred vacuum circuit breaker. Okay, we are not using oil circuit breaker. There has a lot of hazards in the oil circuit breaker and a lot of problems on the sludges too. Okay, and the breakdown of capacity of the oil become reducing if we use the oil circuit breaker, whereas we are not using the air blast circuit breaker too. In the modern rural electrification, all the 33 kV substations are replaced by the vacuum circuit breaker. Okay, so coming to our next question. So in our next question, it is given, the question is, a Thyrite type lightning arrestor. A Thyrite type lightning arrestor blocks, what happens? Blocks the surge voltage appearing in a line, absorbs the surge voltage appearing in a line, offers a low resistance path to the surge appearing in the line, and returns the surge back to the source. Now what actually happens that we are telling? First, the correct answer is option C. Okay, correct answer is option C. What is a Thyrite type lightning arrestor? In lightning arrestor is a non-linear resistor. Non-linear resistor. Actually, whenever the power frequency voltage are present in a Thyrite type lightning arrestor, it will provide a high impedance path to the normal power frequency. whenever a surge voltage appear in the line, then by the virtue of the non-linearity, it offers a low resistance path to the surge voltage appearing to the ground. Okay, of course you can find this question on the book of Rajput MCQ book. Okay, MCQ Rajput MCQ book, page number 32.7 and question number 32.54. Okay, page number 32.7 and question number 32.54. Okay, next move to our next question. Okay, so our question number 3 of this session, that means what is the question is written over here. A 0 to 25 ampere ammeter has a guaranteed accuracy of 1% full scale reading. The current measured by this ammeter is 10 ampere and the limiting error in the percentage for this instrument. Okay, this question was previously asked in the IES, electrical engineering IES 2010. Okay, and JB Gupta, page number 688, you can find this also, the question of the JB Gupta, page number 688, question number 33. Okay, that is very simple. Now we are very interested about this formula of this question, the limiting error. What is the formula for the limiting error? Okay, we are writing the limiting formula for the limiting error, and what you have to do, you have to memorize it. Okay, what is the formula for the limiting error? The limiting error formula is range. What is the range? Range is the maximum value minus minimum value multiplied by accuracy. Okay, what is the accuracy? And divided by the reading. Now what is the range? Here 0 to 25 ampere, that means 25 accuracy. The accuracy is already given here, 1%. Now what is the reading? Reading is 10. Okay, so if I divide the 25 by 10, that is 2.5, and 2.5 into 1, that is 2.5%. okay, that is 2.5%. okay, so 2.5% will be the correct answer. Anyway, whoever has given this exam, okay, you can check the answer key. Okay, PSC will not provide you any answer key. Okay, whatever the answer key given by our channel, that will be the final answer key. Okay, and there will be no deviation in the PSC. Now coming to our next question, one of the very simple question number 4. What quantity of charge must be delivered by a battery with a potential difference of 110 volt to do 660 joule of work? Okay, the work done will be 660 joule. Okay, there is a very simple formula for that. That is the electric potential energy or the work done. Electric potential energy or the work done is equals to the electric potential multiplied by the charge given. Electric potential energy or the work done is equals to electric potential into charge given. What is the work done? Work done already given here is 660. What is the electric potential already given here? 110. And if I multiply it by the charge, I don't know the charge. Now the charge becomes 110, 6. Okay, so C becomes 6. Now the correct answer will be option B. Okay, correct answer will be option B. Coming to our next question. Okay, our next question is question number 5. Question number 5 states that which of the following essential features is possessed by an indicating instrument? Okay, what are the essential feature of an indicating instrument? Okay, you can find this question again. I am telling you can find this question in the R.K. Rajput book of R.K. Rajput. You can find a MCQ book of Rajput over there, very popular, and page number 24.8 and question number 24.7. okay, page number 24.8 and question number 24.7, and the correct answer is all of them. Okay, because and indicating instrument has all the features of deflecting torque, controlling torque and damping torque, and there is a device for deflection, there is a device for controlling, and there is also a device for damping torque too. Okay, so coming to our next point. What is our next question? Let us see what is our next question. Our next question, question number 6, very important question and a very conceptual question too. You can find that for symmetrical waveform, okay, for symmetrical waveform, the average value of one full cycle. What is a symmetrical waveform? Okay, symmetrical waveforms, you can find any one is symmetrical waveform. Okay, if I write a sinusoidal, that is symmetrical. If I write a triangular, that is also symmetrical. Okay, the positive half cycle and negative cycle are equal. If the positive half cycle and negative cycle are equal, that means they are going to be symmetrical waveform. Now for a symmetrical waveform, symmetry of waveform, this can be explained by the Fourier series. Okay, what was the Fourier series says? Fourier series says 0 to t. If I take the sine in sine form, sine m omega t, okay, dt. If I integrate over 0 to t, it becomes actually 0. Okay, if it is a cos m sine omega t, for any value of m, it becomes also 0. Okay, for any symmetrical waveform, we would not interested to take the average value on the full cycle. We never take. Okay, we will not. We would take this for symmetrical waveform. We would take the average value over the half cycle. If the waveform is not symmetrical, then we would interested to solve the waveforms, solve the average value or the total area of the integration over the full cycle. If it is a unsymmetrical, if it is symmetrical, then we would cover the half of the cycle, and if unsymmetrical, full of the cycle. Okay, I hope it is clearly understand, and this can be very easily explained by the Fourier series. Okay, and Fourier series talk about lot of waveforms. Okay, in our later discussion we will talk about the Fourier series too. Next, coming to our next question. Okay, in this section we are very interested about our solution of our question paper. Okay, we are very interested about the solution of our question paper and not interested about the Fourier series. Just we are going to solve, and we have to provide all the answer key to the students who have already given the exam. Okay, next, the two capacitance C1 150 plus minus 2.4 microfarad and C2 120 plus minus 1.5 microfarad. What is the limiting error of the resultant capacitance C? Now in this question was asked. Okay, let me first this question was asked in the UPSC IES 2008, and it can be also found the JB Gupta page number 689, question number 58. Okay, JB Gupta page number 689, question number 58. So what happened, that capacitance are not given if they are either in the series or in the parallel. Okay, for series there will be a different formula, for parallel it will be different formula. We have done both. Okay, we have done both. We have found that in series, whatever will be the answer, that is not given in the option. Whatever be the answer is not given in the option. So we have to take the condition for the parallel. We have to take the condition for the parallel only. Okay. So if I take the parallel combination, this error will be added. Okay, simply the error will be added, 2.4 plus 1.5. Now we are not going to subtract. Okay, we are definitely interested about the addition. And why? Because we are very interesting to find the maximum deviation of the circuit. Okay, we are very interested to find the maximum deviation of the circuit. Okay, I hope this is clearly understood by you. Coming to our next topic. Okay, one point there is, if you like our video, you can share the video among your friends. Okay, and those who are watching our videos, please subscribe us and press the bell icon, because we are going to publish all the 100 questions of this series of the examination. Okay, now coming to the question number 8. What is written here? It is written a spring control moving iron voltmeter. We are very interested about this point, spring control, and that is very important term. Full scale deflection of 150 volts draws a current of 2 milliampere. Now, what will be the meter reading if it draws a current of 1 milliampere? Now, if it is a spring controlled, then the deflecting torque is proportional to I square, or vice versa. That means we can write I square is also proportional to TD. Okay, deflecting torque or deflecting, that is the source voltage. Okay, Vs. Now for 2 milliampere, that means for the 2 square of current, that what will be the voltage? The voltage will be 150. And what will happen to the 1 square? The latter, the current will be reduced to 1 milliampere. So what will be, what is our, that is the core question. Okay, that means if it is linear, that is, if it is directly proportional to I, then we can say that the half, that means 150 by 2 will be the answer. But here there is squarely proportional, that means it will be 150 multiplied by 1 upon 2 square. That means 150 by 4, the 150 by 4, the answer will be 37.5. 150 by 4, the answer will be 37.5. Coming to our next question. Okay, what is our next question? Next question is a very simple topic about the RL circuit, a very simple RL circuit. In a series RL circuit, the voltage across the resistor, inductor are 3 volt and 4 volt respectively. Okay, and then what will be the applied voltage? Okay, this is a very simple formula. The applied voltage will be the root over of VR square plus VL square. Okay, root over the VR square plus VL square, and that means VR, what will be the VR? That is 3 square, and what will be the VL? That is 4 square. Okay, already given in the question. So what we can write, that is root over of 3 square, that is 9 plus 16. So it will be root over of 25, that means 5. Okay, so the correct answer will be 5 volt. Okay, the correct answer will be 5 volt. Now coming to our next and last question. Okay, but before that, we are again a very simple small announcement. That is, we are very interested about the SSC JEE Solve of 2018. Okay, and I hope you all, whatever you are watching, you are very interested too. So if you are very interested, please subscribe us and share our channel video to your friends. Okay, so that we can bring the SSC JEE 2018 solution very quickly. Okay, coming to our last question. What is the question written over here? The question written is, in a permanent magnet moving coil instrument, in a permanent magnet PMMC instrument, the deflecting torque. Okay, PMMC instrument, the deflecting torque. Okay, now in a permanent magnet moving coil, the deflecting torque, what is the TD? Deflecting torque, tau D is equals to BIL N into R. What is B? B is the flux density. What is I? I is the current. What is L? L is the length of the coil. What is N? N is the number of the turns of the coil. And what is the R? R is the distance between the force and the radius of the coil. Okay, so these are the quantities. Now here we are very interested about the number of turns and the flux density. Okay, in all the given options, the flux and number of turns. Now here we can simply write that torque tau D is proportional to flux density if every other thing remain constant. If here we can also write the tau D is also proportional to number of turns if other things remain constant. So what I can write? We can write the deflecting torque is directly proportional to the number of the turns and the flux density of the coil. Okay, so option A will be the correct answer. Okay, you can check. This is the final answer key. Okay, this is the final answer key. The PSC will not deviate any one of them, and there will be no percentage of error, any percentage of error. Okay, all the given options given by us will be the final answer key for the PSC. Okay, and thank you for all for your watching. And if you are watching the video and you don't have subscribed to our channel already, please subscribe our channel and support us. And of course, press the bell icon too if you want to get our latest videos very fast. Okay, thank you very much.